All right, 52 weeks of AWS. I'm back. I had a small little injury to my elbow, and I'm back here though, and I'm going to keep going on the AWS Machine Learning Certification. And I believe last time I was covering forecasting. So I'm going to go ahead and get this pulled up here. Go to a bootcamp and go into my materials. And I think last time was 4, this time, yeah, so I'm gonna go 5. If I remember, let's double check here. Computer. No, I think computer vision, did I cover computer vision or not? I think I did cover computer vision. And so the next one is going to be NLP, which will be a good topic to cover. So let's go ahead and cover NLP here. I'm going to share my screen. Make it larger. And looks good. Okay, so let's go into slideshow mode. And we're ready to go with natural language processing. Let me make this a little bit bigger. But yeah, that's good enough. All right, so with NLP here, there's a few key things to take away. We're going to be talking about how it works in a nutshell, and then also some of the details of the implementation on AWS. And to start with, we can think about the concept of asking Alexa. That's a good typical use case here. You get a recording, and then that speech is analyzed, and you go ahead and do something with it, and the important words are used to perform a task. That's really it in a nutshell. And if we look at what is NLP, though, NLP develops computational algorithms to automatically analyze and represent human language, and the tokenization place is, or a portion of NLP is where you would go through and find words or phrases or sentences, right? So you got to break things up so that you can actually do things with them later. What are some of the challenges with NLP? Well, language is not perfect. People have slang, they have different ways of expressing things. So that's a problem. But in a nutshell, discovering the structure of the text is probably one of the bigger problems initially, like how do you break it out and tokenize it? Next up is labeling. So after you have converted the text to a numerical form, because all machine learning requires a numerical form, then you have to apply the labels. And those should match the language's grammar, and then also the context. The same word can mean different things depending on the context, and then also the grammar, is basically in infinite ways that you can deal with grammar, and you have to deal with the variations of how humans use language. So, what can you do with natural language processing use cases? Search applications are easy. Like I actually use voice search quite a bit. Human-machine interface, right? Interacting with the device, like your iPhone. Sentiment analysis for marketing or political campaigns. This is a pretty big one, actually. I think is as we get more and more sophisticated sentiment analysis tools and pre-trained models, I think we're going to get the general public, I think, will be very good at sentiment analysis. Social research for media analysis, and chatbots to mimic humans. So what is a workflow that you could expect on, let's say, AWS? The first place is to do the problem formulation, right? So you get into what is the business problem, Then you would collect and label the data, so it's preprocessing the text. Then you would evaluate the data, so create tokens and analyze text, do some feature engineering. Once you've got that hooked up, then the new data or retraining data, what would happen is you would tune the model. So you would basically pick what kind of model is going to be the right model, evaluate it, and see if it meets the business goals. If it doesn't, then you go back and retrain it or reformat the problem formulation to fix it, and then you deploy the model, and then you would also want to monitor it so that you can actually go through and validate that it is actually solving the problem after, let's say, 3 months, because things are constantly changing in the real world, like new words are invented. So the first task with preprocessing is to remove the stop words. So this is kind of classic. If you go to Kaggle or you take a graduate level machine learning course, you learn about how to remove stop words. You then normalize similar text. You would standardize unrecognized text as well. There's other preprocessing steps like encoding or doing grammar checks. I use grammar check software all the time, so you would think your code would as well. And then there's a lot of libraries for preprocessing. So there's the NLTK library for Python, for example. There's also Gensum as another one. There's a ton of tools for preprocessing, and some of them actually are good at scale, and some of them are not good at scale. So that's something to be aware of as well. So next up, you would create tokens and do feature engineering. So in this example, we would say from NLTK.tokenize, import word tokenize. You put in a string, like this is some sample text, and you tokenize it. It just does a very simple return of a list with each word inside of the list. Then you would develop a feature by applying a model. So some of the models would be bags of words, which is a simple model that captures the frequency of words in a document. So for each word in the document, a key's created with a value that's the number of occurrences within that document. The term frequency and an inverse document frequency, this would be TF-IDF, is a count of how many times a word appears in a document. Inverse document frequency is the number of times a word occurs in a group of documents. Both of these values are used to calculate a weight for the words. So words that appear in many documents have a lower weight. So an example of NLP model bag of words, you would basically create a vector model. The vector model converts each sentence or phrase into a vector, basically, which is a mathematical object to record directionality and magnitude. And so in this case, the word is a value of 2 because it appears twice. And the bag of words is often used to classify documents into different categories. So a text analysis categories, what could we do? Well, the category of analysis is similar to other classification systems. The algorithm would interact with a classifier model to infer a classification, and you could use the NLTK Python library to create this. You could also discover similarities. So this is a very common one. Like, can you do autocorrect or spell check, or basically you use the Levinston distance algorithm. Is a very common one, and you figure out how similar is this word to another word, and you can do things based on that. You can also derive relationships between different words or phrases. That's a good way to think about it. So capturing the context. So this was mentioned previously. This is one of the most difficult ways of dealing with NLP. How would you capture it? Well, you could tag words with the appropriate part of speech. That's one way to do it. And you also can use a library that will help you do this. So, for example, is it in computing, the context, or is it in medicine, or is it in sports? It makes a big difference. So how do you derive meaning by entity extraction? Well, there's a few ways to do this. There's something called named entity recognition, or NER. And a NER model has the following components. You would identify the noun phrases by using the dependency charts and part of speech tagging. You would classify phrases by using a classification algorithm like word2vec. You could also disambiguate entities by using a knowledge graph. And so this example that I'm looking at is showing that the Titanic and North Atlantic are from the text, and after the name entities are extracted, I can use a knowledge graph to extract meaning. And the Amazon recommendation engine is a great example of a knowledge graph. Okay, what about managed services? So I think that's always an important thing to be aware of on AWS, is that many times a managed service can be the quickest way to solve a problem versus doing it yourself. And Amazon Transcribe is a fully managed service that uses machine learning technologies to recognize speech and audio files and transcribe them into text. And you can use it to convert audio to text and then create applications. So you can record videos, or you can recognize recorded voices. You can make streaming audio, text. You can create specialized vocabularies. You can integrate applications by using WebSocket. And you can also build multiple languages in real time. So that's a pretty cool component, is to be able to transcribe and build subtitles in real time. So what are some of the use cases here? So medical transcription is a big one. So medical professionals could record notes and capture the spoken notes as text, subtitles for video. This is something that is very common in video production, is you want a live feed with closed captioning, but you'd like to actually have it in multiple languages. Also streaming content. So media companies could capture and label content and then feed it into Comprehend for even further analysis. Call center modeling is another monitoring, so you could actually record customer service calls and deal with that. Now, Poly is a tool that can convert text into speech, and you can use either plain text files, or you can use this markup language called SSML markup language. And that format can provide special instructions for how speech could sound. So maybe you want to do a pause, right? So, for a more sophisticated scenario, this could be good to add a little bit of annotation to it. You can also add speech from Poly to MP3, Vorbis, and pulse code modulation, or PCM audio stream formats. Also, Poly has a lot of applications, news readers, games, learning platforms, applications for accessibility for visually impaired, and it also is HIPAA compliant. So what are some of the use cases for Poly? A news service production, a language training system, a navigation system, for mapping, animation production. So animators could use Poly to add voices to their characters. So Poly is pretty cool, and it's worth playing around with. Now, Translate is a service that you can use to create a multi-language experience in your applications. And you can do this by reading documents in one language and then rendering it or storing it in another language. And in particular, it's fully integrated with other services. So Comprehend, Transcribe, Poly, they all can work with it. So you could extract named entities and integrate with Comprehend, do multilingual subtitles with Transcribe, and you could also speak translated content with Poly. So pretty cool tool, actually. And it's able to be used in a very elastic manner as well, so it can handle scale. Some of the use cases would be an international website. Like if you wanted to globalize your website, you could, every time you publish to S3, for example, like I have a few websites that I publish with S3, you could create a translation aspect of it, and every time you generate your English files, you could also generate in Portuguese and Spanish and Mandarin Chinese. Software location. So location is a major cost for all software that's aimed at a global audience. And Translate can decrease this quite a bit. because it's localizing, reducing the cost for localizing, and also multilingual chatbots would be a good use case, and international media management, again, for people wanting to localize their content. So Comprehend is one of my favorite services on AWS because it makes natural language processing so simple, and it does a lot of things that you probably would do yourself, and it can do entity extraction, key phrases, language detection, sentiment, and a lot of other things, or identify the part of speech for a word. And it really is pretty comprehensive, right? You just put in some text. In fact, let's go to AWS real quick here for people that are watching. And if I go to Comprehend Service, it's pretty easy to use if you want to just play around with it. Let's go here, go to Comprehend. There we go. It's part of the machine learning suites. And all you have to do is click Launch Comprehend, and they give you like a built-in one to play with. But we could grab, I don't know, something from like The Guardian or something. And I don't know, the top story today is Pelosi defends Taiwan trip. Let's just take that and let's put this inside, and we'll grab it. Nancy Pelosi defends Taiwan trip as more important today than ever. So if we analyze this, we find it was able to detect Nancy Pelosi as a person, Taiwan as a location, today is date, China as an organization. And key phrases, it was able to find Nancy Pelosi, Taiwan trip. Language, it found it was English. PII, it found Nancy Pelosi in Taiwan. Sentiment, it says neutral. And syntax is, it was able to find all these proper nouns. So really a lot of stuff you get by just, putting it into Comprehend. So some of the things that you can do with Comprehend would be analysis of legal docs, legal, insurance, medical. Maybe you just always pre-process things with Comprehend. Financial fraud detection would be another great use case. Large-scale mobile app analysis, so for people looking at patterns in their mobile app usage. And then content management, you could use Comprehend to tag content for analysis and media management purposes. So maybe you want to add tags to things, before you post your content. Comprehend could be a good use case for that. So Lex is also a neat little service, and what it does is a service for building conversational interfaces for applications. So basically you can automatically increase the capacity by creating Lambda functions, and you could store log files for the conversation for further analysis, but really a kind of a plug and play service that allows you to create chatbots, and you can interface with the rest of AWS. What are the use cases? So inventory management, sales. A lot of people talk to a chatbot to ask for questions. You could also build interactive assistants. Basically build a sophisticated assistant and put some ML in there. You could create a customer service interface, so like human-like voice applications that could use it. Also, you could query a database with a human-like language. So Lex could combine with a database service and hook into it. Right. Well, really to kind of wrap things up, there are a lot of really good managed services on AWS, and in particular for the AWS machine learning exam, definitely you should know the managed services that have to do with machine learning. And in particular, I would say if you're studying for the AWS machine learning certification, anything that's under the machine learning tab, SageMaker, Augmented AI, Code Guru, DevOps Guru, Comprehend, are fair game, right? Like you're probably gonna be asked a question on one of those things, so it's good to be aware of it. And I think there's only one more section here, and I guess I have time. I might as well just kill two two birds with one stone and just wrap things up. And let's go to the next section and go to the course wrap up. All right, so what have you learned? Basically, you should be able to describe machine learning. That's really important. I think a big takeaway for machine learning is that you're converting a problem into a numerical format and learning from the data to make predictions. I think that's typically the most common pattern. Also, that you should know how to implement a machine learning pipeline with SageMaker. So SageMaker Studio Lab is free. That's one way to play around with SageMaker if you want to get a little more experience. And then also using a managed Amazon ML service for forecasting, computer vision, and natural language processing. Let's dive into documentation here. So the good thing about AWS, every company has strengths and weaknesses, but AWS, the documentation is pretty incredible. I've actually never felt left down that much with AWS versus other, software companies. And the white papers in particular are amazing. And a few things to make sure that you're aware of would be to read the basic ones for Cloud Practitioner. So, make sure you have the basics, like what is Amazon Web Services, how do you architect for the cloud, how does pricing work, those kinds of things. And then total cost of ownership is another one. And if we go into the certification, you can see that this is a specialty certification. So there is going to be a higher level of skill in terms of maybe machine learning, or it's a specialty type exam. So you will need to know some of these core concepts. I do recommend that you have most likely taken Cloud Practitioner exam. It's not that hard to take. If you can't pass Cloud Practitioner, I think it's very difficult for you to pass machine learning because it's a basic level of knowledge. So I would maybe start there first, then do the machine learning specialty. So some of the things that you're going to be tested on would be the ability to select and justify the appropriate approach for a problem, identify appropriate services, like again, should you use Comprehend or should you use Transcribe? If you don't know the difference between those two services, even though you may conceptually know the difference between sentiment analysis and transcription, you're going to get stuck. And so the names are really important. Designing and implementing scalable, cost-optimized, reliable, secure machine learning solutions. And then the requirements would be that you have a couple of years of experience, basic ML algorithms, about hyperparameter optimization, ML and deep learning frameworks, and you have the ability to follow model training best practices. These are all super important. And that's pretty much it. So that's really a wrap for what I was going to cover in terms of the AWS machine learning certification. So that's actually, now we have a bow that we could put on this thing. I would say after that, probably the next thing that I could cover would be the AWS developer exam, because I do have a lot of experience building software on AWS, and that feels like a nice next step here. So if you're around next week, I will cover the AWS developer certification, and we'll start going through that, slide by slide. And I would say roughly that would take us like 10, 12 weeks or so to cover that material. So thank you everybody that showed up for 52 weeks of AWS. We've finalized machine learning. Also wrapped up AWS book this week for the most part with O'Reilly. You can see that it's called C# on AWS or something like that. You'll see parts of it appear on the O'Reilly platform, and you can take a look at that as well. So see you next week.